In this video, I'm going to show you how to take the derivative using logs. First thing to know is the derivative of a log and the derivative of a natural log. So the derivative of log of base b of some function, meaning it could be x or it could be a function, is going to be 1 over u times the natural log of that base multiplied by the derivative of u. Natural log is going to be very close to the same thing, except there is no natural log on the bottom. It's just 1 over u times u prime. So let's try this. So here's the first thing that I'm going to show you how to do. First is, because it is not just x, but it is actually a function, I'm going to go over here. Remember, we talk about u as being some function. And so the derivative is 1 over that function times the derivative of that function. So I'm going to go ahead and actually write that. So we know that u is the function x cubed plus 1, because think of this as the natural log of u. And if u is x cubed plus 1, let's go ahead and take the derivative of u, which would give me 3x squared. So I'm just going to keep that over to the side. So we know the natural log of u is 1 over u times the derivative of u. Or you could say it's the derivative of u over u. Same thing. So I'm actually going to write it. I know the derivative of u, it's 3x squared. And I know u, it is the original function, x cubed plus 1. And that is going to be your answer. So let's try another one. We know that u, actually no, we are not going to do u first. Here is where, back in Algebra 2 and Pre-Cal, properties of logs come into play. If I have the natural log of a function divided by a function, then there is a property that states that I can break it up as the natural log in the numerator minus the natural log of the denominator. So I actually can break it up into 2 logs. This is going to be a good idea to do it here because of chain rule, quotient rule that's in play inside this. So I'm actually going to break this up into the natural log of the numerator minus the natural log of the denominator. So let's start with just the first one. U is x plus 1. The derivative of u is 1. So I know that the derivative of this is going to be u prime 1 over u, which is x plus 1. And then minus. Now I'm going to take the derivative of this. U is going to be the square root of x minus 2, or you can think of it as x minus 2 raised to the 1/2, which means u prime is going to be 1/2 x minus 2 raised to the negative 1/2. And then you got to take the derivative of the inside, but the derivative of x is just 1, so you don't have to necessarily keep it. Which means u prime is going to be 1 over 2 times the square root of x minus 2. So the natural log is going to be u prime, which is 1 over 2 times the square root of x minus 2, all over u, which is x minus 2. Now, you can leave it like that, but this actually does clean up. So the first part is x plus 1. The second part is these two denominators actually can multiply together. So you'll get 1 over 2 times the square root of x minus 2 squared, which is 1 over 2 times x minus 2. By the way, the reason that works, think of it as this. the top fraction divided by the bottom fraction. So think of KFC. Keep the first fraction, flip the second fraction, and change to multiplication. That is, oh, sorry, it's supposed to be a 2. And then change to multiplication, and that is actually how you get that. And the square root and the square cancel. And so this would be your final answer. This would be considered the derivative of that. So we're actually going to do it again using a log, because even if you did want just to do the low D high minus high D low over low low, which is totally fine, you can do that. You really, really don't want to do it here because of the product rule with the chain rule with the quotient rule. So here's how you do it. But you're like, well, there's not a natural log in front, so I can't break it up. Actually, you can. I am actually going to take the natural log of both sides. So on the left, I have the natural log of y. On the right, I have the natural log of x to the 3/4 plus the natural log of x squared plus 1 raised to the 1/2 minus the natural log of 3x plus 2 raised to the 5th. Now, here's something else that's wonderful about properties of logs. Any exponent can actually be thrown in front. So this is actually 3/4 natural log of x plus 1/2 natural log of x squared plus 1 minus 5 natural log of 3x plus 2. And now take the derivative. Okay, natural log of y is going to be y prime over y. Natural log of x is 1 over x. So 3/4 times 1 over x is 3 over 4x. This one you're going to have to do the chain rule. So it is going to be 1/2 times the, let's see, what is it again? Natural log of u is going to be u prime times 1 over u, or u prime divided by u. Okay, so the derivative of x squared plus 1 is 2x all over u, which is x squared plus 1. Same thing. It's going to be 5 times u prime, which is 3, all over the original 3x plus 2. So let's clean it up. We have y prime over y equals 3 over 4x plus x over x squared plus 1, because 2's cancel, minus 15 over 3x plus 2. All right, normally you're done, but you're not, because we have a problem. It's not solved for y prime. So what do? You have to multiply both sides by y. Correct? To cancel. So when you do that, you're left with y prime on the left. On the right, you're left with a 3 over 4x plus x over x squared plus 1 minus 15 over 3x plus 2 multiplied by y. Well, what is y? It's the original problem. X to the 3/4 times x squared plus 1 divided by 3x plus 2 to the 5th. And that is your final answer. So if you would like to pause the video, attempt this one, basically having to take the natural log of both sides and then resume to see the answer. So in this one, I'm going to have to take the natural log of both sides. And the reason is because I got to use a property of getting the exponent down front. So I have the natural log of y equals the square root of x times the natural log of x. So now I'm just going to be, this right here is just going to be the product rule. Natural log of y is y prime over y. And then we'll do the first times or the second. So the square root of x times natural log, the square root of x times the derivative of natural log, which is 1 over x, plus the natural log of x times the derivative. Don't forget, the square root of x is x to the 1/2. So it is going to be 1/2 times x raised to the negative 1/2. So now let's solve. You have y prime over y equals the square root of x over x plus the natural log of x over 2 times the square root of x. Last step, you got to get rid of y. So I got to multiply both sides by y to cancel. So your final answer, the derivative is going to be the square root of x over x plus the natural log of x over 2 square root of x times x raised to the square root of x, because that is the function of y. So in this case, you can pause the video, attempt to do this problem, and then hit resume to see the answer. Because this already has a natural log, we can automatically go ahead and just break it using the properties. So this is going to be the natural log of 2y plus 1 raised to the 5th minus the natural log of the square root of y squared plus 1. Now, don't forget, exponents can be thrown in front. So this is the same thing as 5 natural log of 2y plus 1 minus 1/2 natural log of y squared plus 1. Now, you may be freaking out of like, oh my goodness, we got to take the implicit of all these y's. Actually, no. This is in terms of y, which means you can take the derivative just like normal, because that is what the respect is of the derivative. You're doing it with respect to y. So the derivative of natural log is going to be u prime, which is 2, over u, which is the 2y plus 1. And again, on top, it is going to be u prime, which is 2y, over u, which is y squared plus 1. So our answer is going to be 10 over 2y plus 1 minus y over y squared plus 1. Why? Because the 2's cancel. And there's your answer. This is equal to the g prime with respect to y. We're going to do the same thing, except in this case with a trig function. So go ahead and pause the video, attempt to do the problem, and then hit resume to see the answer. Okay, we're going to take the natural log of both sides. Again, why? Because the function is in the exponent. FYI. Take the natural log when your exponent is a function. So I'm going to take the natural log of x raised to the sine of x. Here's why. Because anytime you take the natural log, you have a property that states that the exponent can get thrown down front. And you're now down to a product rule. So let's go ahead and start. The derivative of natural log is going to be y prime over y. And now you're going to do the first function multiplied by the derivative. Natural log of x becomes 1 over x. Plus the second function times the derivative of the first, which is cosine. So to solve, you have y prime over y equals the sine of x over x plus the natural log of x times cosine of x. Now the only thing left you have to do is you got to solve for your y prime, which means you got to multiply both sides by y. So I will get y prime equals the sine of x over x plus the natural log of x times cosine of x multiplied by your original function, and there's your answer. Now in this case, you have a chain rule inside of a product rule inside of a chain rule, I believe. No, chain rule inside of a chain rule actually is what you have. So this is not a natural log. This is just a straight product and chain rule. So again, do not forget, you only ever take the natural log when the exponent is a function. So to do a chain rule, you go outside in. So first take the derivative of cosine, its negative sign, and rewrite the inside. Now you got to take the derivative of the inside. Well, the derivative of natural log, well, this is the natural log of u. So natural log of u is u prime over u. So the natural log of x squared, the derivative is going to be 2x. So the natural log of x squared is going to be u prime over u. U prime over u, which actually nicely kind of cancels. So your answer is going to be negative sine of the natural log of x squared multiplied by 2 over x. So really the only way you can clean it up is you can put the 2 in the front, I guess. And then x stays in the denominator. And that would be your answer.